So we want to look at differentiating our natural exponential function e to the x. So e, or Euler's number, is an irrational number approximately equal to 2.718 to 3 decimal places. Euler's number is the limit of 1 plus 1 over n all to the power of n as n approaches infinity. So our exponential curve looks like this. It goes through the point 0, 1, and it goes through the point 1e, where e is the base of our function. And the function f of x equals e to the x is unique in that the gradient of the function is equal to the value of the function for all values of x. So at every single point on that curve, if we take the gradient of that function, it will be equal to the f of x equals e to the x curve, so it will lie directly on top of it. So therefore, we can say that the derivative with respect to x of e to the x equals e to the x. Now the caveat for that is that we need to note that if a doesn't equal e, then the derivative with respect to x of a to the x does not equal a to the x. And that's where a is any number not e. Because when it is e, then the derivative of the function does equal the function. So on our formula sheets, our standard derivative, if f of x equals e to the power of x, then the derivative of f dash x equals e to the x. And if we wanted to write it in Leibniz notation, if y equals e to the x, then dy by dx is going to equal e to the x. So by the chain rule, if f of x is any differentiable function, then we can say that the derivative with respect to x of e to the power of f of x is going to equal e to the f of x multiplied by the derivative of that inside function. So let's have a look at a couple of examples. We want to find the derivative of e to the power of 7x with respect to x. So we're going to use our chain rule, and we're going to let u equal the inside function 7x, and y is going to equal e to the power of u. So du by dx is going to equal 7, and dy by du is going to be e to the power of u. So we know that dy by dx is going to equal dy by du multiplied by du by dx, and we're going to substitute in our values. Dy by du was e to the u, du by dx was 7, and then we're going to write it with respect to x, so we're going to write that dy by dx equals 7 e to the 7x. Our final example is the derivative with respect to x of e to the power of sine x. Again, we're using our chain rule, so we want to let u equals sine x, e to the u, dx is going to equal cos x, and our dy by du is e to the u. Then we're going to write dy by dx equals dy by du multiplied by du by dx. We're going to substitute in our values, so dy by du was e to the u, du by dx was the cos of x, And then we want to write it with respect to x. So we're going to have cos x multiplied by e to the power of sine x.